Hey guys, Mr. Milton here. Today we're going to talk about exponential functions, growth and decay. At the end of this video, you should be able to identify and explain the various parts of an exponential function, and you should be able to write and evaluate an exponential function. Okay, so let's talk about exponential functions in general form. The variables are x and y. Okay, so those are the things that we're going to change throughout. And notice where x is, it is an exponent. And that is why this is called an exponential function. Okay. A is the initial value. Did I do that right? Yep. A is the initial value or starting value. This value never equals 0. Can't be 0 because 0 cannot grow or decay. Okay. Alright. B is the growth or decay factor. Okay. If it's greater than 1, so if B is greater than 1, then this is a growth function. It gets bigger over time. If B is less than 1, then the function is a decay function, and it gets smaller over time. Okay, B won't be just 1. If it's just 1, then it won't be exponential. Okay. All right, so here we go. Let's look at identifying these various parts of the exponential function here. So here we have y equals 12 times 1.05x. Initial value, 12. Is this a growth or decay function? It is a growth function. Okay. The answer to y is that b is greater than 1. b is 1.05. So it's growth. For number 2, the initial value, 0.4. Is this a growth or decay function? Again, it's growth. Okay, if you said decay or thought decay, remember we're looking at b value. The b value tells us if it's growth or decay. And again, b is greater than 1 because 2 is greater than 1. 3. Initial value, 5,000. Okay, is this a growth or decay? This is decay. Well, why? Well, b here is 2 over 3, or 0.66 repeating. Okay, and that means b is less than 1. Okay, and so the b value tells you whether it's a growth or decay function. All right. So, the population, let's look at some more examples now of writing an exponential function. The population of a city is 50,000 and increases by 3% each year. Write an exponential function to represent the situation, and then tell how many people live in the city after 5 years. So here we go. A is our initial value, right? And so our starting value, we start it with 50,000 population. Okay, our b value, our b value will be 1.03, and follow me for a second. Okay, so 1.03. If you're thinking that that's wrong or different than what's in the problem, follow me. So once you find the a and b values, you can write the function. The a value is typically given, but the b value takes a little bit of work. So the growth rate, because they told us it grows, the growth rate is 3%. Okay, if you guys know percentages, remember 1 is 100%, so 3% you'd write as 0.03. Okay, try to use that in your calculator. Okay, if you're putting this into your calculator, what we would do is we'd say for this, y is the population, 50,000 was our initial value, and then we'd say 0.03 to the fifth power. That's how our function should be written based off of this information if we use 3.03 as the growth rate. So 50,000.03 to the fifth power. If we do that, it says after 5 years we should have 0.001215 people. Does that make sense? No, it doesn't make sense because it says that our population is growing, so we should have more people. All right, when we say 0.03, what we're doing is we're taking 3% of the population. We said we have a 3% growth. 3% growth of what? Of 50,000. So we're going to say 1, because remember 1 is 100. It's 100%, and the 3% added. So we should say 1.03 to the fifth power. And so after 5 years, we'd actually have 57,963 people. Okay, 3% doesn't include the 100% to work towards growth. Say that. Sure, there are better ways to word that, but we're good. Okay. All right. So to find the v-value, take your percentage r and either add it to or subtract it from 1. So our growth value, if it says it's a 3% growth, we'd say, well, it's going to be B will either equal 1 plus R if it's growth, or B will equal 1 minus R if it's decay. Okay, so if it said that the population should decrease by 3% each year, then we would say 1 minus 0.3 or 0.97. Oops, scoot that up so you guys can see that. Sorry, close to the edge. Okay, again, if it's growth, we'd say 1 plus the rate that they're talking about. Okay, because 100% of what's happening plus the rate of growth. Or if it's decay, we'd say 1 minus R, 100% of what's happening minus the rate of growth, or rate of decay. Okay, so let's flip and look at some more examples. So in the previous example, A was 50,000. That was the population that started off with. And I'll probably just do what I did before again. B was 1.03, 1 plus 0.03. And so the exponential function is y equals 50,000 times 1.03 to the fifth. So the population in 5 years would be 57,963. Okay, it says 0.7, but we'll keep it as 63. Okay, 0.7 people, creepy. Okay, all right. So a new car costing $20,000 depreciates in value 16% each year. Write an exponential function to represent the situation, and then find the value of the car after 7 years. So here we go. We need to have our initial cost. Y equals our initial cost, which is $20,000. That's how much it costs or is valued at the beginning. And then it says it depreciates in value 16% each year. So remember that depreciates means that it's decaying. The money is going away. So we say, okay, it's not 100%, it's 100% minus the 16% each year. So 1 minus 0.16 would be 0.84. Okay, and then X will represent how many periods, so 7 in this case. So in our calculator, we'll do 20,000 times 0.84 to the 7. And so after 7 years, your car will be worth $5,901.80. we'll go to decimals there because it makes sense. But all right. After 15 years, the buyer decides to sell the car for $3,000. Is this a fair price? So, how will we know if it's a fair price? Well, it says it depreciates 16% each year, and it tells us it's 15 years. So we're going to look and say, okay, 15. Okay, if you use this kind of calculator, we can go back in our history and not have to type everything back in. Now I'm changing the time period to 15 years. So in 15 years, based off of what they told us earlier, this car is going to be worth to the 15. This car is going to be worth $1,462 and 90, let's say 2 cents. To make it more fair. Is this a fair price if he's going to try to sell it for $3,000? No. No, it's not a fair price. The car is only worth $1,462. He's not going to get $3,000 from it, or he shouldn't. If somebody buys it, they would have got taken for their money. Alright, here's what I want you guys to do for class. Bring this in, complete it, try it out. In the movie Pay It Forward, an idea is brought about by a boy who wants to make a difference in the world. The concept he comes up with is to do one unexpected nice thing for 3 people. Then each of those 3 people are to pay it forward by doing something nice for 3 more people, and so on. Write an exponential function to represent the situation. Remember, you need an initial value. You need a growth or decay rate. Okay, and then x will be the number of rounds. Okay. All right. So try that out. Bring that in. We'll talk about it in class. See ya.